In this session, we will learn how to make the Carpentry vise-led screw. At the end of this session, you will be able to know the Carpenter vise, explain the buttress form of thread, describe the screw thread, turn the component as per drawing and make buttress thread on the component.
Vises are used for holding workpieces. They are available in different types. The vise used for bench work is the bench vise or called engineer's vise. A bench vise is made of cast iron or cast steel and it is used to hold work for filing, sawing, threading and other hand operations. A carpenter vise is an important tool in carpentry and is designed to hold clamped wood without damaging the surface. Wood often needs to be clamped when completing tasks like sawing, drilling or carpentry. There are several varieties of vises available in the market. The following are the parts of a vise: fixed jaw, movable jaw, hard jaws, spindle, handle, box nut, and spring are the parts of a file. The box nut and the spring are the internal parts. To hold a finished work, use soft jaws or vise clamps made of aluminium over the regular jaws to protect the work surface from damage. Clamps are mostly used in pairs for gluing up operations. It provides the required pressure to hold joints together. Basically, clamps are of two types: plain rectangular bar type and T-bar type. The clamps are mainly crafted out of mild steel and is usually rectangular in section. There are other types of clamps available, namely rack clamp, screw clamp, light duty pallet clamp, adjustable bar clamp, G or C clamp, and double bar clamp that are useful for holding different sizes and shapes of wooden jobs. The profiles for external and internal threads with clearance on the non-load bearing flank on the minor diameter but with no clearance between the load bearing flanks or on the major diameter nominal size is indicated in the diagram. The profile for external and internal threads with clearances on the minor diameter and on the flank standard nut system but with no clearance on the major diameter is indicated in this diagram. Have a look at the formulae associated with the dimensions indicated in both diagrams. The diagram figure 4 shows the profile for multiple start threads. PH indicates lead and P refers to pitch. Multiple start threads have the same profile as single start threads with lead pH equals pitch P. For the pitch P of multiple start threads, only the values permitted for the lead P of single start threads may be selected. However, the multiple of the pitch P of multiple start threads need not correspond to the value permitted for single start threads. Thread is a ridge of uniform cross-section which follows the path of a helix around the cylinder or cone either externally or internally. Helix is a type of curve generated by a point which is moving at a uniform speed around the cylinder or cone and at the same time moves at a uniform speed parallel to the axis. Threads are used for fastening purposes. Example, bolts and nuts. Transmission of motion. Example, half nut with lead screw. Precision measuring instruments. Example, micrometer spindle. Load lifting purposes. Example, screw jack and elevating arm of radial drilling machines. Elements of thread means naming the parts and other terms systematically. The parts of a thread are major diameter, minor diameter, pitch diameter, pitch of the thread, crest, root, flank of the thread, thread angle, depth of thread, lead angle or helix angle, lead, hand, clearance, and major diameter. Root or bottom is the bottom surface joining the two adjacent flanks of the thread. Flank or side is the side of a thread surface connecting the crest and the root. Crest or top is the top surface joining the two sides or flanks. P indicates pitch in millimeters or threads per inch. Beta refers to the profile angle. Phi refers to the helix angle of the thread. D is equal to the major diameter, external or internal. D1 is equal to the minor diameter, external or internal. D2 is equal to the pitch diameter, external or internal. Pitch diameter is the effective diameter of the screw thread, approximately halfway between the major and minor diameters. Helix angle is the geometrical shape of the screw thread. It is based on the pitch diameter of the thread and the pitch, that is, the distance from one point on a thread profile to the corresponding point on the next. The formula for calculation is shown here. This measurement can be represented by a triangle being unwound from the component. The same pitch on different diameters gives a different helix angle as shown. Let us see how to turn the component as per drawing and make buttress thread on the component. To do this, you need the raw material, cutting tool, 4-jaw chuck, buttress thread, measuring tool, undercut tool, threading tool, and drill chuck and drill bits. The job sequence is as follows. Check the raw material size. Hold the job in a 4-jaw chuck and screw it. Face one end and center drill the job. Reverse the job and face the other end to a length of 280 mm and center drill it. Hold the job in between center. Turn helix angle 30 mm to a maximum possible length. Chamfer the end 2 by 45 degrees. Reverse the job and turn the step helix angle 25 mm for 255 mm length. Turn the step helix angle 7 by 8 inches or 22.2 mm for a length of 215 mm. Turn the step helix angle 18 mm for 15 mm length. Set the undercut tool of 5 mm width and make undercutting to the given depth as per the drawing. Set the threading tool of 45 degrees and 90 degrees to the correct position. Set the machine to cut 9 TPI thread. Cut the 9 TPI buttress thread. Deburr the job and check the dimensions.
We have reached the end of this session on Make the Carpentry Y-slit screw. By now, you should be able to know the Carpenter vise, explain the buttress form of thread, describe the screw thread, turn the component as per drawing, and make buttress thread on the component.